Let us see how your project will look like when it is running. Let's now see the contents of our project folder, which contains the 3 text files plus the source code for the client and the server. Let me run the server first. The server is running right now on port 12,345. Let me split my screen into 2. On the left, the server is still running. On the right, I have a new terminal screen where I will be running my client software. I will first send the fruits.txt file to the server, but before that I will go to the Wireshark and start listening on the loopback address. Why the loopback address? Because I am running both software on the same computer. That's why I am using the loopback address, which is 127.0.0.1. Now the Wireshark is listening. I'm back on my terminal screen. I'm running the client software. As you can see on the left, the server has got the connection from the same computer, and the received message is fruits.txt. It has created a new file and saved this message into that new file. This file has the name, IP address, and the timestamp, as you can see, and also created a log file where it has written the name of this file together with the size of the message into that file, and it's still running, waiting for another client connection. Now let's look into the folder and see what are the files that are created now. Here is the log file having the file name 1234567 Your file name will contain your student number here instead of 1234567. Let's have a look into that file. As you can see, it contains the newly created file name plus the size of the message. And also, let's look into the contents of the newly created file. It contains exactly the same message as the fruits.txt. Now let's go back to the Wireshark. and see that we have a lots of traffic on it. By looking at the length, I can see that this is the TCP packet that I'm interested in. When I choose it and come down here, I can see the data, which is 338 bytes, the exact number that is saved on the file. And when I click it, it's only a byte stream that is not readable by me, and I want to see it in a readable form. Hence, I will be going and making the packet bytes window visible. And as you can see here, we have the hex code for this byte stream. On the left we have the byte stream, on the right we have the ASCII part, which is the readable part. Hence you can see the apple and watermelon and etc. The contents of the file is now readable by me. Now I will return back to the terminal screen, where now I will run the software with the client software with the lorem.txt. Coming back to the server screen on the left, I will scroll it down. Okay, the receipt message starts, and after displaying a page, it stopped and expecting a key press enter to continue. It continued and it saved this new contents into the new file name. The IP address part is still the same, but the timestamp has changed. Also, it has logged this text file into the log file, and it's still running, waiting for another TCP client connection. Coming to the right screen, let me clear my screen first. Let's have a listing of the current folder. Now you see we have a second newly created file, which has a timestamp different than the first text file. Let's look into the log file to see if that new file is registered in that. Yes, this new file name is registered, and the message size is 8,447 bytes. And let's have a look into the newly created file, okay, which is the timestamp 044244. Now I expect to see the contents of the lorem.txt file, which is exactly the thing that I'm seeing. Now let's go back to the Wireshark. Scroll down to find the TCP file, TCP packet, by looking at the size. Okay, as you can see here, the data is 8,447 bytes, exactly the size logged here. And also by choosing the byte stream on the right, I can see the contents of the file in ASCII. Okay, let's go back to the terminal screen. The server is still running on the left side. On the right, I will be running the client software. With the alice.txt, which is the biggest of the text files. You see on the left, again the message is received by the server, but it will be stopping at every page waiting for my input. So I keep pressing the enter until I finish the display of this message. Okay, the message has finished. The server has saved this new message into a new file. Again, the IP number part is same, but the timestamp has changed, and also the logging of this file name into the log file is successful, and the server is still running. Let's look into the current folder and see that the new file is being created. But first, let's look into the log file. Log file says that this new message is 148,540 bytes long. Now let's go to the Wireshark and find the TCP packet for this message. You see now we don't have a single TCP packet because the size of the text file is much larger than a single TCP packet. Hence, we will be seeing this message in multiple packets, starting with packet 107, and the last packet is 116. And when you scroll down here, you can see that it's the end of the packet. So this packet has been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different TCP packets, and all that has been handled by the operating system and not by my program. Okay, that's how your programs should be running and behaving.